In sections 11C and D, we're going to start looking at the line of best fit for data. So in the last lesson, we talked about correlation. We kind of sketched in. Here's the paper I have. So we sketched in this line of best fit, but we want to have a more precise way of finding that, something more exact that would help us generate that line of best fit without having to just say, it kind of looks like it would be about right here. So we're going to look at the way to more precisely find the line of best fit. So in 11C, we're going to talk about the way to estimate it. So in order to kind of guess where the line of best fit goes with a more mathematical way of doing this, the first thing we're going to do, step one, we are going to calculate the mean of the x values and the mean of the y values. So we're going to calculate x bar, which is the mean of x values, and y bar, which is the mean of y values. Okay? So we're going to do those two things. So I'm going to do this with the example problem that we worked with last time, which was the phone calls and text messages. So here's my data for phone calls and text messages. We can calculate the mean of the x values pretty quickly by adding them up and then dividing by 8, because there are 8 total students here. Then we could do the y values by adding them all up and then dividing by 8. And so that's a really good way to do this. So I'm going to, let's see the best way. I'll just copy this table over again. Okay, so we've got our 8 students, and here's our data that goes along with them. Okay, so let's calculate the mean. So our phone calls was our x, our text messages was our y. So I'm going to add the values up and then divide by 8. That's how we find mean. So 4 plus 7 plus 1 plus 3, 0 plus, 2 plus 2 plus 4, let's see. That's 8 values, that's all of them. That's 23 divided by 8, and that gives us a mean of 2.875. So that's our means, okay, our averages. We can do the same thing for our y. So 6 plus 9 plus 2 plus 5 plus 2 plus 8 plus 4 plus 7. 43 divided by 8 total, so 5.375. Awesome. I'm going to show you the way to do this in your calculator if you maybe have a lot of data and you don't want to do this by hand. So I have under stat, edit, I have my list typed in from last time. So I have my phone calls in my X column and my text messages in my Y column. So that's all typed in. I'm going to press stat, go over to calculate, and we've used the 1var stat button. So that's how we found mean, median, mode, all that for a list of data. That was in chapter 6. Last time we used number 4, which finds your R value to determine your correlation. This time I have 2 variables. So one variable statistics found all that mean, median, mode, standard deviation, that type of things for one set of data. Here I have 2, so I'm going to do 2 variable statistics. Press enter. My X value was list 1, that was phone calls. Y value was list 2. I don't have a frequency list, and so I calculate, and it's going to give me a lot of information. What it pretty much does is gives you your 1var statistics, but it does it for both sets of data, the X's and the Y's. So X bar is here, that's the mean of my X values. This sigma is the mean, or is the standard deviation for X. There were 8 terms. There's Y bar, so there's the mean for the Y. So let's see if we got those right. So X mean, check. Y mean, Y bar, check. Okay. There would be my standard deviation for Y, and then we got all of our mins, maxes for X and for Y. Good. So That's another way that you can find your mean, especially if you already need to have your data typed in here to find your R value. Then you might as well just also use this 2var statistics to calculate your mean for you. Okay, so that's how we got to that. So there's our means for our x's and for our y's. Step 2 is we're going to plot the mean on our graph. So we're going to plot the mean point, which is this point, xy. I'm going to go to my graph that we had from last time. I'm going to pick another color. It was in pink the first time, so how about green? And I'm going to graph the point 2.875 for my x. Okay. And 5.3. Right about there. Okay. Then we are going to, step 3 is we're going to draw on a line that goes through the mean point that's in trend with our data, and we want there to be about the same number of points above and below the line that we draw in. So I'm going to draw in a line. Let's see. There would be 3 above. That seems a little extreme. I don't know, about like that, right? Maybe a little steeper. Okay, so this is just a one where you still have to kind of guess, okay? But it has to go through that mean point. So we are going to sketch or draw, let's see, step 3. Now this is not a precise instrument. We still are kind of guessing, but we at least have our mean point that we're going through. So the IB exam likes having you find and graph the mean point. That's a very popular question that they like to ask. So draw a line through the mean point. Okay, so we're going to draw in a line that's in trend with the data. So you can think like about the same number above and below, just kind of in line with that increasing data. All right, so that's still a method that is not precise, but we could find that line. So what's the more precise way to do this? So in my calculator, whenever we went to once again I have my list typed in into list 1 and list 2. So when I went to stat calculate number 4 linear regression last time, and we went through all these buttons, calculate, it gave me more information than just the Pearson R value. So whenever you do linear regression on the calculator, so whenever you press stat, calc, number 4, linear regression, it gives you some information. So it gives you y equals ax plus b at the top. They tell you your a value. They tell you the b value. They tell you the r squared value. They tell you the r value. Okay, and there's our value. So last time we looked at the r value, we said that it's positive, it's close-ish to 1, so it shows a strong positive linear relationship for this data. The r squared value we're not going to deal with, so we're not really going to work with the r squared valued. But the a and the b value are very important, and they have to go with this right here. So this is our y equals mx plus b. The calculator just uses a's and b's instead. And so this value tells you your slope. This value tells you the y-intercept. So our line of best fit for this data is y equals a, so 0.98, I'm going to go 3 sig figs, 5, x plus b, which is 2.54 b. Okay, so this is the precise best line of best fit as calculated by our graphing calculator. So, how would this line look graphed over here with my data? So, a couple ways you can do this. I like using the graphing calculator when I can. So we could go to our y equals and actually graph the line, 0.985x plus 2.54. This isn't going to help us much because it's here and we want it over here. So if we go second graph table, we could plot some of these values. So let's kind of plot some of these and see what this would look like. So I'm going to use orange, 0 and then 2.5. 1 and then 3.5-ish, okay? 2 and 4.51. 3, 5.49. 4 and 6.48. Okay, 5 and 7.46. So that orange line represents my line, okay? So notice it is going through my green point. We said that our line of best fit from 11C will go through that mean point, and it is. Good. It's following in line with my data. This is the precise line of best fit. A good way to do it is type it in your graphing calculator, generate a table, and then plot some of those points, okay? So why do we care? So what does the line of best fit help us do with our data? So it helps us do two things. Well, really one thing, but it has two different names. So we can call, there's interpolating. Okay, so interpolating, okay? This means that we can find data values that fall between the data that we have. So in order to interpolate would mean that we can use this line of best fit to estimate data that falls inside our box. Okay? So I've kind of put that data inside of a box. If you wanted to say, okay, so a student that receives 5 phone calls a day, how many text messages do we would expect them to receive? Okay, we could use this line to help us figure that out. That's interpolating. That's inside of our data, okay? We can also use this to extrapolate. And extrapolate means to extend past our data. So past our data would say something like 9. So I didn't have any data for students that received 9 phone calls, or 8, okay? 9 and 8, 10, 11, 12, these are all outside of the data values that we observe. And so to figure out this value, we would be extrapolating. And extrapolating is not as precise. So there is error that can happen whenever you try to go outside of your data values. So there's more error that is possible, okay? So interpolating is okay, using the line of best fit to find values within the data. Extrapolating is finding finding values or estimates outside of the data. Okay, interpolating versus extrapolating. Interpolating is much more reliable, where going outside of your data is less reliable, we would have to take note of that if we wanted to go outside of our data. So what kind of questions could be asked with this? So I need another piece of notebook paper. So if we're dealing with that same example problem, we could say something like, using your line of best fit, approximately how many phone calls would a student receive if they receive, let's do something that's extrapolating, that's outside of our data. So how many phone calls would they receive if they receive 13 texts? Okay, it's approximate. This isn't like a for sure answer. We're using our line of best fit to guess. Give us a best guess using this data, using what you found. What's a guess? What's an estimate of how many they would receive? So what's important to know first is that phone calls are X and text messages are Y. So phone calls are X, text are Y. So what we know is the Y value. So approximately how many phone calls, how many X would the student receive if they receive 13 texts, which is Y. So my equation here, I don't know X, that's phone calls. I do know Y. Okay, and we would solve this for X. So subtract 2.54. 13 minus 2.54 gives me 10.46. Then we divide by 0.985. And we get 10.6. Okay, so we can't receive part of a phone call. But let's see how this looks on our data. So if they receive 13 texts, that's going to go off my graph. So 6, 7, 8, 9, 10, 11, 12, 13. Okay, 10.6. Okay, so there-ish. Okay, so you can see that does fall kind of within our data. So 10.6 was our X, 12 there-ish. Okay, so it should be in line with this orange line. It should be in line with our data, showing that it's increasing. Okay, but it is just a guess. Now that is extrapolating because it's outside of our data. If I ask the same question, but instead of 13 text messages, I ask something like 5. Okay, so 5 would fall here, then that would be interpolating because it's inside of our box. All right, thanks for watching. Make sure that you're using that graphing calculator, finding those R values, you're finding your line of best fit, and then we're going to use that to find additional values.